When we build systems that scale, we have to engineer the chaos out. You cannot run a complex operation on probability. You need order. But right now, we are treating artificial intelligence like a magic chat box. We type a prompt, cross our fingers, and hope the probabilistic engine spits out the right answer. It forgets what it was doing an hour ago, and if it doesn't know what to do next, it just guesses a path forward. Put that in charge of a real operating environment, and things break quickly. An ungoverned model will get caught in infinite execution loops. It will issue destructive system commands because it misread a log file. It will burn through your compute budget trying to solve a problem it doesn't understand. To solve this, we have to stop treating AI as an assistant and start building it as deterministic infrastructure. We need a system where intelligence is predictable, governed, and mathematically safe. We achieve this by designing a zero-trust operational machine. In a secure setup, the AI model isn't the user interface at all. It is a highly constrained reasoning engine, very deep within a strict, rule-bound architecture that checks every single move it makes. Because an intelligent system that operates without rules is a liability. If it can act without being governed, observed, or replayed, it will inevitably corrupt its own environment. We call this the MotherMAE operational fabric. It's a multi-tiered architecture. To understand how it maintains control, we have to start at the absolute foundation. This bottom layer is the execution plane, powered by a system called OpenClaw. OpenClaw operates strictly as the kinetic hands of the entire machine. It reaches directly into the operating system. It can read and write to the local file system, execute raw Python and PowerShell scripts, control a headless browser, and trigger scheduled actions. But there is a deliberate vulnerability here. OpenClaw has all the physical power to manipulate the system, but it has zero long-term memory. It reacts to immediate inputs, entirely blind to the larger strategic goal. Letting it run independently is like handing a steering wheel to a driver who can only see 3 feet ahead. That raw execution has to be supervised by a higher layer that actually knows the map. This diagram shows the topology of the stack. We move up to the middle tier, the orchestration plane. This is the supervisory routing layer that tells the hands what to do. This plane is managed by Hermes. When a massive, complex task comes in, Hermes acts as the executive. It breaks the plan into phases and spawns separate sub-agents to execute that work in parallel. To keep track of all those moving parts, Hermes maintains a temporal memory graph. It maps the context of strategic goals, ensuring the AI never forgets its purpose. It even uses a biologically inspired dreaming subsystem. It takes unstructured logs from a day's work, passes them through light, deep, and REM processing phases, and consolidates them into a searchable database. Instead of losing everything when the terminal closes, the system retains what it learns. Temporary session data becomes compounded, durable knowledge. But memory and execution still aren't enough. We need an apex authority, a layer that acts as the operational constitution for the entire digital nervous system. That top layer is MotherMAE. It is the control plane, and it holds strict zero-trust governance over both Hermes and OpenClaw. It enforces the rules. This chart illustrates the first law MotherMAE enforces: determinism. If you give the system the exact same input, it must produce the exact same result, every single time. No guesswork, no variation. The second law is idempotency. You can send the identical execution command 10 times, but the system will recognize the duplication and only ever execute once. It prevents sending 100 identical messages to an external server. Every single action generated by the lower planes must pass through MotherMAE's Open Policy Agent validation mechanism. If an action violates the system's strict permissions, it is blocked immediately. There is no bypassing this checkpoint. We cannot afford to trust systems that make decisions we can't audit. By enforcing mathematically rigid, replay-safe governance, we build an infrastructure we can actually trust to run autonomously. When you stack these tiers together, the kinetic execution, the cognitive orchestration, and the strict zero-trust control, they form a single governed machine. We have completely moved past the chat interface. We have converted implicit, messy conversational requests into an explicit, hard-coded operational topology. It runs continuously in the background. It reads the telemetry, spots failures, diagnoses the root causes, and pushes autonomous repairs. It is a living, self-maintaining digital nervous system. Typing instructions into a prompt box relies on constant human supervision for every minor step. It breaks the moment you walk away from the keyboard. But a fully deterministic, governed infrastructure scales human capability. It takes the fragmented limits of individual attention and expands them, granting a single person the operational bandwidth of an entire enterprise.